I've got a lot of asks for this one. How do you actually vibe code a backend? And it's a pretty reasonable question because a lot of the time when we're vibe coding, we're thinking about what something looks like and not necessarily how it functions under the hood. Backend work is also a lot less visually apparent to people. When you make a change on the front end, you can immediately see what that component looks like with that change. On the back end, that is not always the case where you have some really visceral change based on something you've done. If you've tried to build features outside of a platform like Replit, for example, you've probably experienced a lot of frustration around this. Random libraries that you don't understand being added to the project. Database migrations failing and you don't even know what a database migration is. Front-end components that are breaking because you're actually sending the wrong data type to the back end and it can't handle it. Complex relationships between different tables inside of your database. Definitely a different world than front-end development. So today I want to show you how you can actually vibe code a backend using Python. And we're going to do it through the context of a small project. So I have a very basic AI chatbot that is not hooked up to any backend yet. It's just using fake front-end data and mocking up what some conversations look like. So we're gonna take that chatbot and show how you would think about starting to build a backend for it. So I'll show you each of these main concepts and tools in an order that you could actually roll them out in a real project. We'll talk about what the tool is, how to actually put it in your project, and why it's important. Now, these concepts apply to any project. So while I'm using Python in this example, this applies just as much to anything you'd be building, for example, in JavaScript. So a challenge to all the beginners out there, try to think through your next project from the perspective of the backend design, because at the end of the day, it's the backend that really powers the business logic of your application. And considering it only as an afterthought is a losing battle. So first up on our list, let's actually choose a backend framework. Now, there are a lot of options that you have here depending on the language that you are using. For example, if you were gonna build in Node.js, you're gonna do a full stack JavaScript kind of thing. Express.js is a great framework for building backends. But for this Python project, we are going to use Fast API, which is a high performance, easy to learn, fast to code, ready for production API framework for Python. So here is the app that we are going to be working with. So there's some basic pre-populated data. Okay, this is just populated on the front end. It's not actually hooked to any back end. And I have this basic little chat interface that I spun up. I can come through here, I could say stuff to it, and it will return me a response, hopefully in a second. There we go. Sends us a response. I can go up and say, hey, I want to start a new chat. I can say that, but then we'll notice when I refresh this screen, it doesn't persist, right? So none of this is actually storing anywhere. So this is the app that we're going to go in, and we're going to try to actually hook this all up to an actual backend. So I will be separating the backend into a separate repository. So I have my main chat app right here, and then I'm going to go into the chat backend, and that's where I'm going to start building everything out. Now, I am going to be using Claude Code for this, but you could use any system that you have. I'm just going to use this because I find that it's very easy and obviously it works. But again, you could do this using the actual chat inside of Cursor or any other language model or AI agent tool that you have. Now, I'm not going to go try hard mode and try to really engineer out this prompt. I'm going to try to be pretty basic and vibey with it. So we're going to ask it to build me inside of chat backend directory a very basic fast API Python configuration with a single endpoint to test server health. So the last thing I'm going to do, I'm going to hop over to playbooks.com and I'm going to pull a basic rule for a fast API implementation. And so this is just kind of describing some basics of how this thing should function. Okay, so I'm doing this just so that I have like a base of how to at least kind of do things well. So I'm going to hop back into Cursor now, and I'm going to say, use these rules to guide your build. Okay, and so we're going to send that through. Now it's going to do its thing, and then we will pop back as soon as it's done and move on to the next step. All right, guys, so that took, I don't know, a minute at most. And so basically it's created our server for us. And so if we were to go in now and spin up our server, we can see that it's running. And so if we were to go hit that and say, for example, hit like the health endpoint that I asked it to make, we can see that it gets a response. And so if we were to go look in our terminal now, we can see that we have a server running locally on our computer. So that's obviously pretty straightforward, right? We now have a functioning server that we could deploy somewhere, and it obviously doesn't do much. It has one endpoint that we can hit that says health, but hey, we have a server that is up and running. So once we've got our basic server up and running, I want to now create a database that we can really easily, keyword easily, go look at as a non-technical person and kind of understand what's being created, what's going on. So for that reason, I am going to use Supabase, and we're going to connect to Supabase locally from our computer, and then we're going to be pushing all of our data up to Supabase. So let's talk about how we can actually connect that now that our server is actually running. So we're going to head over to Supabase, and obviously go through, create a free account, and then we want to create a new project. Now I'm going to give this project a name called AI Chatbot, okay? And then we need to give a database password. Now you want to remember what this password is that you're about to put in, because we are going to need it later. So I'm going to go generate that password, and then all I'm going to do is hit the create new project button, and then I will rejoin you in a second. Okay, so we did that, and now we land on a page that looks just like this. And so what we want to do now is we want to go up and we want to hit this little connect option, okay? And then this screen is going to pop up. We want to take this first option for direct connection and just copy that to our clipboard. And so now what we can do, we can head back to our project, and I'm basically going to say, help me create and configure a Supabase connection. Here is the base URL. Create the environment file and make sure it's loaded into. So I'm going to paste what that base string was. I'm going to leave it with just your password sitting right here. Okay. And then I'm going to say go. And then what it's going to do is it's going to create me an environment file here. I'm going to go into that environment file off screen. And all I'm going to do is update where it says your password. I'm literally going to copy paste that password that I had copied earlier that I told you to save onto. We're just going to be using that password, and we are not keeping the brackets in, okay? It's replacing this string right here. We're going to paste in our password, and then we will come back on, and I'll continue walking through. Okay, so while this is actually still going, you should really get in a habit, especially if you're learning something new, like backend development, of going to read what is actually going on. So we have this main.py file, which is like the main hook in to our application. And so if we scroll through here, we can see that this is where the app, the server in this case, is actually being instantiated, right? So it's saying we have our app, which is a extension of Fast API, which we've imported into our project, right? So we're saying, hey, go create this Fast API application. And then we can see down here where we had our basic server health endpoint that got configured, and we're going to go into this later on with all the different endpoints that we have and everything. So pretty basic, very, very, very bare bones setup. But now we can see up here where we have from config import settings, right? And from database import DB, okay? And so now this is being used inside of our server, right? So if we were to go in here, we can see that it's awaiting the database connection, right? So it's going to spin up the server and it's going to wait for the database to be connected. So we can actually go look at those files that we created. So this, for example, is our database configuration file. Now, if you really wanted to understand what's going on here, for example, you could copy all this over. You could go in here. You could go to chat or ask and say, explain to me how this works, right? And it's going to go through. It's going to break down all the functions, and it's going to explain to you how the connection to the database, or like the instantiation of the database, actually works. So we can go through, look at our database file, and then we can look at our configuration file as well and follow that same path where we're asking it, hey, how does this thing actually work? And it's going to go and it's going to break down everything for us. So I highly recommend you do that if you're very new to this, because it's going to help you get these concepts into your brain. So now we head back and we start up our project again, and we can see that it is connected successfully to our database. So kicks off the startup of the server. It's waiting for the app to start off. We remember that connecting to the database was part of that startup cycle. It connects to the database, and then it says, hey, our server is up and running. So we've got our server up and running. It connects to our database. The next question becomes, what are we going to put in there? What does the data look like exactly? How many tables do I need? Why do I need them? What's the relationship between different tables? So this is where we start getting into the concepts of our data schemas and types. Now, the tool that we are going to use for this in this specific example is called Pydantic. Because the thing is, when we start making backend requests and we're pulling things from our database and we're doing all of these different sorts of operations, we're modifying data, we're storing it, we're sending it to users on the front end, we're having them interact with it, send it back to us, and all of that type of stuff, we need to make sure we're really sure about what our data looks like. What is its form? What is its structure? What's inside it? Is it the correct type of thing that we're expecting it to be? We need to really make sure we know all of that stuff. And so this becomes a real necessity, especially when you want, for example, to catch a bug before it hits production. Maybe you're writing some code for a front-end request and you have a few different pieces of information you want to send. The content, the role of the user sending it, and a timestamp. Well, what if it's not even a supported role type that's being used, and the timestamp is not actually a valid date? Especially if you're vibe coding stuff and you're not coding this by hand, you need to make sure that your models are in place to catch those sorts of things, because a language model, for example, might use a wrong format, or they might hallucinate what a role type might be and send that through in the request. And then if you don't have validation in place, you might start injecting, for example, or inserting bad data into your database, which would not be good. And so that is what having, again, backend schemas, like models for our data and what they should look like and the type of data they should be working with, right? Is this field accepting or receiving the right type of information? Is it a string field that's for some reason now receiving a number? That might really jack up some other stuff. So we need to make sure it's not happening and identify that validation error early on in the process. So here is the prompt that we are going to use in order to do this. Okay, so we're going to say, check out the core app inside of our repository chat app. And then I want you to build out the Pydantic schemas for the database tables, right? So what is the validation layer for interactions happening with the database? What should those tables be? What should the columns be? What type of types do they accept? Same thing for inbound API requests and the format they need to be in, external API responses and what format and validation they need to be in, and any other mission critical validations based on my app structure. And so again, this is going to go through and it is going to start creating all of that, and we will come check it out as soon as it is done. Okay, so while this is going, we can see there's now this new schemas directory that's been made. And inside of each of these, we have schemas for the different functional areas of our application. Now, I will say there's different theories and philosophies about how to structure the backend directories. For example, I have all of these in a folder called schemas. Some people prefer to group things by features, right? Where you might have a feature that's the chat interface, and then all of the routes and schemas and things associated with that are in that specific folder. So this isn't necessarily the way to do it, but I just want to go through and explain to you guys what this is doing. So if we were to look, for example, inside of our chat schema, we can see kind of how this is starting to shape up, right? So for example, a chat can have a status, right? And the status is a string, and it's any one of these strings. A chat can be active, it can be archived, it could be deleted. So if I was to send a request to my backend trying to update a chat status and it said something like drafted, that would obviously cause a validation error, because that is not a state that this thing is allowed to exist in based on how I've created the validation layer. That is the intent of a tool like Pydantic. Similarly, if we were to go check out our message schema, it's going to be a similar thing. And for example, if you wanted to know how some of this might work, you could come through, you could copy some of these, and you could go ask the chat to explain how these schemas work, right? And then it's going to go through, it's going to read what's there, and it is going to use that in order to educate you about what this thing actually is, whether or not it's good practice, all of that type of stuff. And we can see that now it's replying and it is giving us examples and kind of showcasing how everything works, right? Where the front-end user request comes through, it runs through this validation logic layer, right? And then it interfaces with the actual database from there. And so it's just giving you examples and explaining how these different pieces actually work. Okay, so we've got our server, it's up and running, it's connected to a database. There's a validation layer in place now so that when a request comes through, it has to be validated to make sure that it's the right structure of data and it's meant to be what it's meant to be. But how do we actually effectively get it into the database, right? We have these users, we have chats, we have messages, all of this stuff. How do we make sure that that gets from our front end and the conversation that's taking place into the back-end Supabase setup that we configured earlier effectively? Well, that is where we have certain tools called ORMs, Object-Relational-Mapping tools, and this concept of database migrations. So without getting into the weeds on things here, Postgres is a relational database. Languages like Python and JavaScript are object-oriented languages, which, long story short, means if we want to make things easier on ourselves, especially as beginners, we want to be able to interact with that database like we would interact with code in our project. So for example, if I want to insert a user into a database, or say I want to read every single user that's ever had a chat that is also on my highest paid plan, and I want to be able to analyze their usage in the app. So for example, let's say that we had different tiers of users. We had a medium tier, a small tier, and a large tier. And we wanted to know of all of the medium tier customers that haven't upgraded, we wanted to see maybe what their usage was. So let's say we let them use different language models, and we wanted to see which language models people on that medium tier actually use, if it differs really in any way from people on the highest tier. And maybe we would want to conditionally render some sort of upgrade discount for people that are on that medium tier. We wanted to build all that logic in. If we wanted to go build a SQL query or like a query to Postgres to do all of that, it would kind of be a little bit involved, right? But if we did that with a ORM tool like SQL Alchemy, we'd be able to just make very basic object programming like requests, right? We could say users.find and then put what the tier was and then say .sort by usage, right? And just do all of these really easy commands in order to actually get that data. So it's going to make our relationship in working with the database a lot easier. And it also can help us do database migrations, meaning if we were to go update something about our data at a later point in time, let's say that we were going to add in a functionality where people could actually store conversation summaries into a vector database. And that vector database was then going to be able to be queried for like some RAG type functionality. Well, maybe we store all of those vector summaries in their own database tables, but we want to have a linked relationship to the conversation table where the chat was taking place so that it knows if it needs the summary to go out and find that ID in another table. And we want to so now add that column into our current app. Well, you don't just go and add the column, right? You need to actually do it in a way that it doesn't break the actual production database that you have going on. So here's what we're going to come down and do. We're going to say configure SQL Alchemy in my app and run the first migration to create the tables inside of Supabase. Okay, so what we're telling it right here is, hey, I want you to go out and I want you to configure SQL Alchemy so that we can work with Supabase in an object-like way when we want to query it. And then I want you to actually go through and create the first set of tables, right? So we're going to have like a user table, messages, which are associated with an actual chat conversation, right? There's going to be some different relationships and different tables that need to be getting made. And so we're going to tell it, go create all of that stuff. And then once it's done, we're going to look at the output. All right, guys, so that just ran through. And now if we were to pop back into Supabase, right? So go to your project overview inside of Supabase and then scroll on over to database. And if we were to come look at this now, we can see that there's a bunch of stuff in here. So it actually created all of those database models or database tables. So message attachments with all of the validation that we had inside of our schemas. So messages, for example, are in here. And if we scroll out, we can see all the different things we created. So chats, chat invites, users, sessions, user preferences, all of these different tables. And now these little kind of dots that you see scrolling along are showing us where things are related. So for example, the sender ID in the message connects through to the ID of the user, right? So the sender ID in the context of a chat message is linked to the user that sent it. So we're creating all of these different relationships between the different pieces of our backend, right? Pieces of our database. So now we have all this stuff set up. The database is up and running. We can query the database. It's actually created all the tables that we wanted it to create. We can interact with it. The only problem really is that we don't actually have a way to create a user. All of that front end data we were looking at was mocked data, right? So there's no way for me to actually go in as a user, register, and then authenticate into the app and see only conversations that are mine. So because Supabase is, again, a fan favorite, we're going to go through and set up a basic user signup flow with Supabase. And in total vibe code fashion, we're just going to say, please configure a basic registration page and login page that utilizes Supabase for authentication. Add any, or tell me any fields that I need to add to our environment file. Okay, we're going to let that go, and then we're going to come back and see where it's at and if there's any other configurations that we need to do. So one important thing you should keep an eye on when you're developing is that there's really a difference between just like authenticating, right? Having an authentication system in place, and specifically putting authorization checks in place. So what I mean by that is when I was finished with this, and we can't see it now because it's in the middle of doing stuff, and I navigated to that root domain, localhost 3000, so the main app root, it was showing me everything still. So the fact that I had created this Supabase authentication, it didn't really matter because it was still letting me interact with the back end of my app. So similarly, if I was to come over here and hit this endpoint, like despite the fact that I'm not logged in as a user, it is still letting me hit endpoints in the app. And so there's a difference between just creating an authentication workflow and then going through your app and making sure that critical pieces are not allowing users to access them if you don't want them to have access to those things. So going through like a hardening exercise where you look through everything and make sure that you're not only authenticating a user, but that you're authorizing, put in authorization checks into every important root in your app is super important. So now if we come in here and we go to the account creation flow, we can see we get this error 422 unprocessable entity. Now, this is the function, right? This is actually the purpose of having those pedantic schemas in place so that if there is a malformed request or something's coming from the front end that it's not expecting, it is going to reject it. So when we're in our development process, we can see that something is jacked up, okay? So we are going to go through and we are going to fix it, right? And so this is a really good example actually of why you use schemas, right? The register request schema has strict validation requirements, password complexity, accepted terms of service, etc. And so those things, we didn't actually build them on that front end form, even though the back end is built to require them. And so it's rejecting based on the schema, right? It's saying this is not valid. I'm not going to let this request through. And so we need to modify those things, obviously, because this is an example and we didn't actually build all that stuff out. So now if we hop back, okay, now we have all of this schema validation in place. Oh man, sorry guys, I'm having to update the password on the fly. Okay, so it is emailing us to verify the account. And if we were to go into our Supabase table now, we can see that the user was created, right? So this is me. I just went through, I registered. So now this sign up flow is fully connected. So it goes from me putting in my name, email, password, and now I end up as a unique ID inside of Supabase. So we know that that full end-to-end from front end routes the request through the back end, creates the user in Supabase, has validation in place. That whole piece is working. And now once I'm logged in, we can see that it's scoped properly, right? There's not all this dummy data. I have a blank screen. Obviously, this isn't a good empty state for an app, but I'm in here. I should be able now to go through, create a new chat, have a message conversation, and have those things store in the backend. So we can pop up here, hit create new chat, and again, unprocessable entity. And so again, we can go back and paste that in and try to get some feedback on why this thing is broken. All right, so now we can see as we come through and we hit, for example, to create a new chat, creates a new chat. And if we pop back over into Supabase, we can see those different chats populating here inside of our table. So if I refresh it, we can see the third one. So that is now working, right? So we can create users, we can create new chats, we can link that user to the actual user that created it, right? So if I was to click on this little link thing, it's going to show me what that linked ID is. So it's linking me to myself as a user, as the person that created this chat. So let's think for a second what would happen if we had a feature where we could send our entire conversation off to a large language model, and it would take the entire conversation and it would summarize it, and then it would export it and send it back to us as a PDF. Now let's say it took like 15 seconds to generate the summary. It took another like 10 seconds maybe to construct the PDF. Took another 5 seconds to upload that PDF to like AWS or some cloud storage. So all in all, it takes like 30 seconds in order for it to go through and do its whole thing. Well, that's 30 seconds of blocking time. Like if you were sitting there waiting for a response from the server to do all of that stuff, the user would just be sitting here locked out, waiting for that thing to happen. And obviously, that would be a terrible user experience. So now imagine that we scale this app up to hundreds of thousands of users, and it's not just generating a quick little PDF, it's processing videos, it's processing images, doing all of this type of stuff. We need a system for it to be able to effectively handle background tasks. And so that is what a task queue does. It allows us to offload computationally heavy tasks to a backend process so that the front end stays freed up, the user can get quick responses, and the app can send those responses to the user when it actually has them completed. So let's set one up and actually see what it looks like. So here we are back in our project, and we gave this basic prompt through to get this Celery task queue handled. So I said, I'd like you to build me a Celery task queue system that can handle processing the LLM requests, both the title generation and the main responses. I'd like to specifically have a visual display of the queue progress so that we can actually look at this thing. And so what I mean by this is when I come in here and I create a new chat and I say something like, what is a dwarf star, right? So it goes out, it hits the LLM with this question, and the LLM returns this response to us. Pretty cool. And so I want to pass off this processing to a task queue system. Because again, imagine there's tens of thousands of users all doing this at the same exact time. I want that task kind of offloaded so that it can just receive the response when it needs the response, and it's not going to slow down everybody's front-end experience. So let's look at what the to-dos were. So they were going to install Celery and Redis, create the configuration, create the Celery tasks to actually handle that, the title generation and the responses, then create an API endpoint for it, and then give me a visual system to kind of show what this looks like. So if we were to go look at what this looks like in practice, we can go to our routers and we can go to this Celery file that we have. So inside of this file, we can see that we have these two imports. So we're importing celery.result, and then we're importing the functions that are going to actually generate the title and generate the response from the LLM. And so we can see those get imported from right here. So tasks, LLM tasks. If we go in there, we can see where all of the Celery functionality is actually being configured. So if we were to actually come down and look at some of these functions, we can see that Celery is being used to generate those responses, right? So it creates a task ID, and then it goes through and it actually generates a task that gets placed into the Celery queue, and then it's basically going to process and run in the background until it has actually completed that response. And we can see that right here. So it's going to now kind of registers this task, updates the state of it as, hey, we're about to process this thing. And then it goes through and loops through, and it runs this function. So it's going to run the generate chat response async function, which is right here. And we can see as we look through this, that this is actually creating the prompt, creating the message that gets sent through to, in this case, OpenAI, right? So it's going to call OpenAI with our actual messages, and it's going to wait for that response. Now, to make this kind of more real, let's look at what this would actually practically look like. So we're going to go into our backend, and I created a test function here called Celery Burst which is going to demonstrate what this actually looks like, right? So imagine this use case. We have 5,000 users and they're logged in and they're all trying to send requests at the same time. So we can see what this actually looks like, right? Where the tasks start with a generic pending status, and we can see that we're actually sending real requests through to the backend. We're saying, what's the capital of France? Tell me a joke about Python. Explain quantum computing. How do I do this? How do I do that? Write a haiku, right? It's doing all of these things. It's even asking to generate titles. And we can see that, again, if I hit this, processing. So these are all processing in the background. They can be pulled from the front end then to say, hey, yeah, the task status is done. Therefore, give me the response, right? There's a few different ways that you could then get this data out of your backend and into the front end. But again, this was a very basic prompt where we're prompting, I think it was OpenAI 3 point something, I think was the model we were using. 3.5 turbo, so very fast for basic stuff. And so it only took a few seconds. But again, you can imagine if this was image uploading or video uploading or other resource intensive tasks, each one of these could take 10, 15 seconds, right? And so we can imagine how having that queuing system in place is what's going to allow the front end to continue operating while we get a huge influx of tasks that need to be handled. And so the way that this ultimately integrates with our app is that when the front end does something, right? Like when I sent this message through, it would send this through to an API route that is configured to actually handle the task queuing, which is the function that we were looking at in the code. So yeah, guys, that's it. So we started with basic, just a front end. None of the back end was set up or working whatsoever. And now we have a setup where we can come through. We can say something like, what's the closest Earth-like planet to our solar system? Right? Can ask it a question. We can get out a response. It will save all of the messages. It will save the conversation data. We can go into Supabase. We can see all of those conversations. We can see that they're associated with us as a user, right? So fully functional backend realistically. So now the things you want to make sure you're getting dialed in over time are the best practices, right? How are you going to structure your backend? Are you going to structure it with, routers grouped together, schemas grouped together, services grouped together? Are you going to group it by feature? All of those are things that you want to consider. What type of technology are you going to actually use for each of these features? But at the end of the day, the fundamentals are going to stay the same. All right, so that's it, guys. Vibe in a basic backend. When we started, this was a front end with nothing attached to it, and we went through and set up everything we needed to, right? From the frameworks for the API, the database to store the messages and the chats in, the data schema so that we could validate that the data is the way it needs to be, the authorization so that only we can see our chats, the ORM so we could send things back and forth, the task queue so that if we got thousands of people that started interacting with this thing, that would be able to actually handle it without crashing, all of that good stuff. So this is by no means exhaustive. Backend development is a very involved, complicated thing. You have security, performance optimization, continuous integration and deployment, scaling your application, right? There's a lot of stuff that goes into it, but this should hopefully serve as a really good primer for people that are beginners, right? And you see terms like SQ Alchemy show up in your project and a migration that starts breaking and you don't even know why it's running a migration in the first place. This video is for you. If you want to see more vibe coding content like this that is focused on a specific domain like backend development, for example, leave a comment below the video telling me exactly what you want to see and I will record something. So that's it. I will see you next week. Peace out.